In this video, I'm going to go through an introduction to factoring, and then we're going to talk about the first type of factoring that we're interested in learning, and that's the greatest common factor. So first, let's discuss what factoring is. You might even have kind of a memory about factoring things before in your math career, okay? But let me just kind of recall what it is. Factoring is rewriting as multiplication. I think that's one T. Rewriting as multiplication. My writing's a little sloppy. Let me zoom in here. Okay, so the idea is you probably have seen it with something like this. Let's say you were asked to factor, how about 12? So to rewrite this as a multiplication, there are like several ways to do that, right? One way would be to just do 1 times 12. That'd be kind of the most boring way, but it would work. Another way would be 2 times 6 or 3 times 4. And that would be it. Those would be the ways we could factor 12, okay? But you might recall that they often asked you to prime factor, and that's a little bit different. So a prime number is a number that is only divisible by 1 in itself. So an example of a prime number would be 2 or 3, not 4, because 4 is divisible by 2. 5 would work, and 7, and then we'd have to skip all the way to 11 and so forth. Okay, so those are prime numbers. And when you prime factor, you might remember the factoring tree. They kind of do this like little tree where they break up and they're like, okay, so you start with two numbers and multiply to be 12. Like, let's do 2 and 6. 2 is a prime, but 6 is not. 6 can be rewritten as 2 times 3. And those two are primes. So 12 can be written as 2 times 2 times 3. Or if we want to be really cute, we could do 2 squared times 3. All right. That is how you would prime factor 12. The idea being that we have now rewritten 12 as a multiplication. If we were to multiply these numbers out, it would be the answer. And technically, all of these would be the answers to factoring 12. Okay. All right. So now that we kind of understand how factoring works or what it means, before we do that, we want to do the reverse of rewriting as multiplication because we're going to now apply this to polynomials. Okay. Real quick, let's just review a polynomial. Polynomial is something that maybe looks like this. How about 3x plus 5y squared minus 9? Okay, that would be a polynomial. So it's the sum and difference of these kind of terms that have variables and numbers. Sometimes they don't have variables or sometimes they don't have numbers, but yeah, that's a polynomial. And we're interested in factoring something like this. Now, not necessarily what I just wrote here. This is actually a terrible example, 2 different variables in there, but we want to somehow figure out a way to write it as a multiplication. So let's review multiplying with polynomials. And this is what it is. It's distribution. And you probably remember this concept. When I want to distribute, that means I'm going to take what's in the parentheses and multiply it by the term outside the parentheses. So I would take this 5 and I'd multiply it by both the 2x and the 7, which would result in 10x minus 35. Okay, so kick it up a notch. Let's do this 3x. Let's distribute that. So that's going to give me, oh, sorry, let me put a little box around that. Okay, that's going to give me 12x cubed plus 18x squared. Remember, we're adding the exponents, right? So on the x, there's a 1. On this 3x here on the outside, right, there's like a little invisible 1 on that x that I'm adding with the 2 on the very first term. Okay, so that x and x squared, that's giving me x cubed. x times x gives me x squared. And then for the last term, 3 times 8 is negative 24. And then we just carry the x over into the answer. Okay, so just reminding ourselves here, let me take a second, do this. There are ones on these variables, little invisible exponents that are 1, and that's what we're adding when we distribute for the variables. Okay, so here, let's practice that again. Now we have 2 variables. So for this first term, I'm going to get, okay, so 6 times 3, we'll take care of the numbers, that's 18. All right, now let's look at a. So a cubed times a to the second. We're going to add those 2 exponents together, and that's going to be a to the 5th. And then because there is no b term, it's just going to carry into the answer, so b squared. All right, so let's multiply it now by the second term here. So 6 times 2 is negative 12. All right, so on both that a and b, there are little exponents of 1 sitting there. So when I multiply the a's, I get a to the 4th when I add 3 and 1. And for the b's, I get b cubed when I add 2 and 1. And then for the last term, so the number 6 times 9 is 54. And okay, so there's no a's, so just a cubed. And then b squared times b squared, that's just b to the 4th. Notice we tend to keep the numbers, the variables in alphabetical order. It wouldn't have been incorrect to have written 54 b to the 4th a cubed, like if you reversed these last 2 variables, but we tend to keep it in alphabetical order when we rewrite these. All right, so we're finally ready to talk about the greatest common factor. So the greatest common factor is the largest number and or variable that can be divided by each of the terms of a polynomial. Basically, the greatest common factor is creating a distribution. So it's like a reverse distribution. Try to draw my R. There we go. Distribution. All right. And just a quick note that I want to point out, because this is something that's going to be important later. Any polynomial with at least two terms could have a GCF. I'm going to highlight that. That's an important fact that we are actually going to reference later on. Okay. So basically what I'm saying is that a greatest common factor, or GCF, is kind of like the most basic factoring, and therefore it's something we're going to kind of get into the habit of looking for. And a lot of our factoring is going to be using it. So we want to practice this and feel really good about the greatest common factor. Okay, so let's look at this first example here. I want to rewrite this as a distribution. So basically, I'm looking for a number that both of these terms have in common. And I notice that for the numbers 14 and 49, they have a 7 in common. So I could rewrite this with a 7 outside parentheses. And then inside the parentheses would be 2w, because 2 times 7 is 14. And then for the 49, that's going to be 7 times 7 is 49. And what I have here is, if I distribute this, I get back to what I started with. It kind of looks like a funny Z. So here, let me fix it. There we go. So I get back to what I started with. And that's what's kind of nice about factoring, is we could always check our answer and make sure we did it correct by actually distributing it back out. Okay, so let's look at a more exciting example. Let's see, 24m minus 40n. Okay, so a number that both 24 and 40 have in common. Now, because they're both even, I know 2 goes into both of them. But I also notice that 4 goes into both of them. In fact, 8 goes into both of the numbers. And we don't want to just use 2 or 4. We want to use 8, because we are finding the greatest common factor. So we want the biggest amount possible to be factored out. So because 8 goes into both terms and it's the biggest amount, that is what we want to factor out. So if I factor out 8, I get 3m minus 5n. And that's done. Now here's what's kind of cool. There's like a trick that I like to use to make sure I've gotten the GCF. So here, I'm just going to write it next to it. Like, let's pretend I factored out 4. I just didn't notice that 8 worked. And let's say I have 6m minus 10n. Now, this that's left here, that 6 and 10 have another number in common. They have a 2 in common. So that means that 4 was not the GCF. So I didn't pull out the greatest common factor because these two have another factor in common. All right, so that's how we know that that was not the GCF and that there was something bigger. So we go with 8. All right, and that works. Okay, now let's consider this next one. This is kind of, being a little bit trickier. Let me zoom in a little bit more here. So for this one, there's no numbers in common, but they do both terms have x's. So I can factor an x out. Now, when we're factoring variables, we are looking to take out as many variables as we possibly can, okay? Now, this first term here has x squared, which means it technically has 2 x's, right? It has x times x. But the second term, 8x, only has 1x, which means the most I can pull out is a single x from both terms. So let's do that. Let's divide or factor out an x and rewrite it as a distribution. So that means if I factor out an x, I have one x left over in the first term and only 8 left over in the second term. No x's because I factored it out. And if I distribute this, right? Remember, if I distribute this, I get back to what I started with. All right. So here's let me backtrack on that. Get rid of that. Okay. Let's try again. Let's do a more exciting one here. This is a trinomial. So I'm looking to see what I can factor out. So the first term has 4 x's, the middle term has 3 x's, and the last term has 2 x's. So I can only factor out 2 x's because the last term only has 2 x's. So I kind of have no choice. I end up kind of picking the lowest one because that's going to be the one that I am able to factor out, or lowest exponent. So I'm going to factor out x squared. And then what I'm going to be left with, I'm dividing these terms by x squared. I'm going to be left with an x squared. In the middle, I'm going to be left with just a single x because x cubed divided by x squared. We're subtracting the exponents. That's giving me x to the 1. And the last term, I would just have a 2. No x's. And that would be factored. Okay, let's try another one. So this one, I'm actually going to have both a number and a variable. So I'm looking at the two numbers, and I definitely know 2 works. 38's kind of odd. So I'm going to start with 2, and we'll just see. And I noticed that for the y values, y squared is the smaller of the 2. So that's going to be what I'm able to factor out. Okay, so let's try that. Let's see if that's our GCF, and we'll make sure by looking at the result. So 2 into 16 is 8. I'm factoring out y squared, so there's no y's left over. 2 into 38 is 19. And I'm factoring out y squared, so there'll be 1 y left over. All right, and that can be our answer. Typically, though, a lot of people like to rewrite the last term in descending order. So they would often take the moment and like switch it around. They would rewrite that as 19y plus 8. In fact, some people might even, before they begin, rewrite it in descending order, starting with the y cubed plus 16y squared. Like they like to kind of put it in that descending order. I honestly don't care, but I wanted to mention it just in case that does become an issue when you're trying to input your answers. All right, so let's try this one, another one with a number and variable. So let's start with the numbers. So it looks like 5. 5 is like, since the last number is a 5, and I know 5 goes into both 25 and 80, I think 5 is going to be it. And then the smallest of the x's is x cubed, the smallest exponent there, x cubed. All right, so let's factor. So 25 divided by 5 is 5. X to the 7th divided by x cubed is x to the 4th. Subtracting those exponents. Let's see, 80 divided by 5. Oh, that's funny. I actually don't know. Let's see. 80 divided by 5 is 16. And that'll be x to the second when I'm subtracting the x cubed from the x to the fifth. And actually, this last term, they both divide out. So I'm left with a 1. And you've got to put the 1, right? Because you're dividing 5x cubed by 5x cubed. Because I want to be able to distribute and get back to what I started with. And if I don't have the 1 there, I'm going to be missing that last term. So it won't be 0. There'll be a 1 because we're dividing 5x cubed by 5x cubed by itself. So it's going to leave us with a 1. Okay, so a couple more exciting examples here. For this one, whenever the leading coefficient is negative, whenever it's negative, you're going to want to factor it out. Okay, so because that's negative and it happens to be the one with the highest variable, right? It's in descending order. I'm going to factor out a negative, and then let's see. I know 6 goes into all the terms. Actually, 12 works. 12 works. Okay, and I'm going to factor out negative 12 because that first term's negative. And then let's see, for the z's, it looks like z squared, since that happens to be the lowest of the z's. So that's the most I'll be able to factor out. Okay, so here we go. For the first term, we're going to be left with 3 z to the 7th minus. So because I'm factoring in a negative, that's going to change that middle sign, right? So that's going to be a negative 2 z squared. And then the last sign is going to become a positive, and that'll be 5 nosy. All right. Nosy. That's funny. Sorry. Sounded like I said the word nosy, like being nosy in something. All right. Let's try this last one. So this last one has 2 variables. Very exciting. Let's look at the numbers first. 3, 9, 15. Okay, 3 definitely goes into all of those. Looking at the x's, it looks like the smallest one is x cubed. And for the y's, the smallest one is the y in the very first term. Okay, so let's write what we have left. So since we're factoring out a 3, that first term is not going to have a 3 anymore. It is going to have an x to the 4th and no y's because I'm factoring the y out. Second term, I'm going to be left with a 3 again, or a 3. And then x, just x to the 1, right? Because subtracting the 4 and the 3 on the x's is going to be x to the 1. And then for y to the 4th, I'm factoring out a y, so I'm treating that like having a 1, right? An exponent of 1. So that's going to be y to the 3rd. And then the last term, we're going to have a 5 when we divide 15 by 3. Negative, of course, just drawing the minus in front. And then no x's. X cubed is going to get factored out, but we will have a y to the 5th when we subtract 6 minus 1 for the exponents. And that's kind of as complicated as they'll get for the GCF having like multiple variables like that. We tend to, when we have 2 variables, we let the dominant or first variable x, in this case, making sure it's going in descending order, so the highest value starting first. But really, I'm not too stressed about us getting things in descending order. I just kind of wanted to make a comment that the y's were not in descending order, just the x's were.